Hey and welcome. Today we are going to solve move zeros interview question. This is one of the easy problems, so let's get into it. First example here. We have an array of numbers like that and we want to move all zero element to the end of it in place. So we have two zero elements here and here, and in the output they move to the end at here. Second example, we have only one zero and we return that zero since it represents the beginning and the end of the array. So our algorithm might process that as it is. Let's see how we are going to solve this problem. The idea for solving this problem is a bit clever, to be honest, because think about having two pointers where one of them moves fast and the other one is slow. As an early hint about this slow pointer, I can say that it's only going to track the zero elements count. Let's say that our fast pointer is the one which is responsible for iteration, but other than that loop, we will have another pointer that we will manually increment it based on some situation. And that situation might be when we are iterating through the array with help of the fast pointer and we see a non-zero element. When we see a non-zero element like this one here, we should increment the index of the slow pointer because we don't want that to be out of sync as we go through the iteration. And then, of course, move into the next iteration cycle. But if we see a zero element like this one here, we will skip it and no increment for a slow pointer in that case. The reason behind skipping it is that later on we want to leverage the slow pointer and use it to switch the next non-zero values location we see with the index of our slow pointer, which at the time will still going to point to the index of the zero element we just skipped. That will come here to rescue us. So as a result, the non-zero element will replace the zero value of slow pointer that we just visited. And of course, we will have an increment to the slow pointer's value. So this process will keep happening with help of fast pointer until the end of the array. And as you can see, we will switch the values once again here and increment the slow pointer one more time. But we are still not done yet because we did just first half of our work. If we take a look at our slow pointer value, it points up to the index that exactly the last zero element was existed, which means if we do another loop over the array, but this time start from that exact slow pointer's index, we are safe to replace every element that comes after that index with zero. It could be an override of zero or any non-zero value. Doesn't matter at this point because we already moved all non-zero elements to before that index with help of previous iteration. And by that, we are done moving zeros to the end of the array in place. That was the second half of our job here. Now let's jump into the code to implement it. First, we will define our slow pointer, which will be initiated as 0. Then our simple iteration over given array, which will represent the same fast pointer we discussed. Within this iteration, we only need to do some stuff when we hit a non-zero element. If we see a non-zero element, we need to replace that value with the index that slow pointer points to currently. And then, of course, increment the slow pointer for making it ready to be used by next iteration. Now, the first half of our work is done. The second half is about cleaning up and placing the non-zeros at the end. So for that, we might have an iteration from slow index until the end of the given array, and we are safe to place zeros one by one after that index because we already moved the non-zero elements prior to that slow pointer's index with help of the previous iteration we did. So we will do a while loop. And within that, we will place 0 at the index of the slow pointer and increment the slow pointer by 1 until it hits the length of the given array and consequently exits the loop. Now, if I run this, test cases are passing, and if I submit, we are in a good shape here. Now let's jump into the time and space complexity analysis. So the time complexity will be O of n since we just do 2 iterations over the given array and the second one usually starts from somewhere in the middle. But of course, the worst case could be an array with only one non-zero element that would still cause us to iterate at least from index 1 to the end of that array. And as you might know, O of 2n would result in O of n. So we should not worry about that part. And the space complexity will be O of 1 since we only just had a single variable of slow pointer. So that was it for this video. Thanks for watching, and please leave a like, comment, and subscribe to the channel. I will put the link for Arrays playlist and a few other ones in the description for you to check it out. And finally, hope you enjoyed this video and stay tuned for the next one.